Yes, next derivation on the same module. General equation for unsteady flow condition towards a well in this form. Okay, general groundwater flow equation for unsteady flow condition in this form. Okay, we need to derive this derivation for unsteady flow, okay, towards a well in this form. Now carefully observe the diagram, very simple diagram. Okay, ground level is there, pumping well. Once the pumping starts, water level slowly decreases. So this is cone of depression. Water level decreased around a well. So this is cone of depression. Okay, from the center of the well to some, h is equals to depth of flow corresponding to radial distance r. Any distance, okay, any distance for corresponding h. Depth of flow, h means depth of flow corresponding to any radial distance, corresponding radial distance. Right? Okay, now consider h is equals to thickness of the aquifer. This is thickness of the aquifer. H is equals to thickness of the aquifer. Small h means what? Depth of flow. This is depth of flow at any radial distance r. Just I said. Okay, h means the depth of flow at any radial distance r. And S means storativity. You studied all these things in module 2 itself. Okay, please remember the previous concepts. So, S nothing but storage coefficient or storativity. A means area of the aquifer, which is equal to 2 pi RH. Area of the aquifer, which is equals to 2 pi RH. H is depth of flow corresponding to radial distance r. You can take h here also, from here also, okay, but corresponding radial distance. Now, according to the storativity, okay, according to the storativity, you know from module 2, you know all these things from module 2. Dou V by dou T equals to dou H by dou T into SA. Volume per time, nothing but discharge, correct? Volume per time, meter cube by second. Volume per time, nothing but discharge. Okay, you can substitute this, okay, into this. Volume per time. So you can rearrange the terminology. Dou Q by dou R into dr. Dr cancel means discharge, small discharge. Okay, let's say very small one. This is very small discharge of radial distance dr and depth of flow dh. D, nothing but very small. Dou H by dou T into SA. You call this equation as 1. This is from module 2. And volume per time is just replaced by dou Q. I written here. Where dou V by dou T nothing but rate at which the aquifer releases water. Nothing but discharge. Volume per time, rate at which aquifer releases the water. Aquifer releases the water. Okay, pumping. Or takes into the storage. Okay, recharge from the aquifer. V nothing but volume of the water released per horizontal area of the aquifer. Volume of the water released per horizontal area of the aquifer. Okay. Dou H by dou T nothing but rate of drop of water level. Rate of drop of water level. Initially the water level is here. When the pumping starts, water level slowly decreases. So this is cone of depression. This indicates what? Drawdown. Okay, rate of drop of water level, water table. Now from the Darcy's law, we know velocity V equals to K into dH by dr. So Q is equals to AV, area as it is. V, Darcy's law, V is equals to K into dou H by dou R. We know area 2 pi RH of this aquifer. Just substitute area equals to 2 pi RH, K into dH by dr. Now 2 pi, this is R into K nothing but transmissivity. Okay, we know all these things from module 2 itself. Okay, thickness into permeability, you will get transmissivity T, dou H by dou R. Now just differentiate this equation with respect to R. Differentiate this equation with respect to R. Dou Q by dou R equals to 2 pi T, take R inside, so differentiate with respect to R na, dou by dou R of R into dH by dr. Constant term, take outside, d by dr, differentiate with respect to R, so d by dr of R into dH by dr, R into dH by dr. Now dou Q by dou R equals to 2 pi T, just apply the product rule. Okay, first term as it is, derivative of second term. First term as it is, derivative of second term. So dou square H by dou R square plus second term as it is, derivative of first term. Okay, just apply the product rule. Okay, so second term as it is, derivative of first term, dr by dr is 1. Dr by dr is 1. Okay, now substitute dou Q by dou R from equation 1. So just substitute this value by this equation. Listen, dou Q by dou R nothing but dou Q by, this is dou Q by dou R nothing but dou H by dou T into SA. Dou H by dou T into SA equal to 2 pi T as it is and rest of the thing as it is. Now dou H by dou T into storativity into area we know 2 pi RH. Okay, 2 pi RH equals to 2 pi T dou H by dou R, R into dou square H by dou R square plus R into dou square H by dou R square. Same, just substituted this area. Now take R common. Take R common, dou H by dou T into S as it is, 2 pi RH as it is. Take R common from this term. From this term, 2 pi T as it is, take R common, so this term becomes 1 by R into dou H by dou R plus R common dou square H by dou R square. Okay, now here 2 pi R cancel, right? 2 pi R cancel. The remaining term is, okay, listen, the remaining term is, just take this T to this term. So this S by T into dou H by dou T, take T to the left, take T to the left, so that becomes S by T into dou H by dou T equals to the remaining term, dou square H by dou R square plus 1 by R into dou H by dou R. Okay, this is the same equation, just we derived in this form. Okay, dou square H by dou R square plus 1 by R into dou H by dou R equals to S by T into dou H by dou T, where where this H becomes unity. Let's say depth of flow H is unity. Depth of flow H is equals to unity. So this is the final equation in the required form. Okay. Hi, welcome to the new session. Today we are going to continue with the module 3 itself. Next topic in module 3 is interference of wells and its effect. Interference, the name itself is suggesting interference, nothing but overlapping, correct? Interference, nothing but overlapping. So interference of well and its effect. What are the effects of interference? What are the effects of overlapping? I'll tell you everything in detail. Listen to me. Interference of well and its effect. First of all, carefully observe the diagram. Okay, this is well 1. Okay, this is well 1. This is another well 2. Both are closely spaced. Okay, let's say about 200 meters. Okay, or 100 to 200 meters. It's a closely spaced well in a single aquifer. Okay, this is well 1, this is well 2. Discharge from the well 1 is Q1. Discharge from the well 2 is Q2. Nothing but pumping. Okay, discharge nothing but here the pumping. Discharge Q1 from well 1 and discharge Q2 from well 2. Okay, this is aquiclude. Aquiclude if the aquifer is a sandwiched, if the aquifer is confined between two impervious layer, then we call it as aquiclude, correct? Confined aquifer. This is aquiclude. Aquiclude nothing but it's a formation of clay, nothing but impervious layer, isn't it? This is impervious layer. If the aquifer confined or sandwiched between any two impervious layer, then we call it as confined aquifer. Okay, confined aquifer. The wells are penetrating deeper into the ground, so that is penetrating the confined aquifer. Okay, x is the center to center distance between the wells and r is the radius of influence, m some meters of distance between the two impervious layer. Some meter of distance, let's say for example 5 meter. 5 meter distance between the two impervious layer. Okay. Once you start the pumping, okay, water level, this is initial piezometric level. Once you start the pumping, the water level below the ground will decrease. Obviously, once you start the pumping, once you start extracting the water, pumping start. Once the pumping starts, the water level below the ground will be decreasing. Listen, the water level decreased. This one, yellow color. So this is the drawdown curve for well 1. Drawdown curve for well 1. Drawdown. Yellow color is the drawdown curve for. I told you in the previous class what is drawdown and all. Please go through the previous video. Drawdown nothing but the decreased water level. So once you start the pumping, the water level going to decrease. So after decreasing, so this is the level. Yellow color, drawdown curve for well 1. This is. Similarly, if you start the pumping in well 2, same thing will happen. Drawdown will happen, means water level is going to decrease. So this is orange color. This is the drawdown curve for well 2. Okay, this is a zone of influence. Okay, this is for well 1 from here to here is the zone of influence. Similarly for well 2, from this line, from the orange line, so this line from here to here, this is the zone of influence, correct? The yellow color zone of influence is interfered, is overlapped by drawdown of well 2, correct? So this is the drawdown curve for well 2. Yellow color is the drawdown curve for well 1. Orange color is the drawdown curve for well 2. So this zone influenced by, overlapped by this orange drawdown curve. So this is what interference of well. Okay, interference nothing but overlapping. This region, okay, this area overlapped by this drawdown curve, correct? So now this one, pink color, this is the pink color is the composite drawdown curve. Okay, pink color is the composite drawdown curve for both well 1 and well 2. This is drawdown curve for well 1, drawdown curve for well 2. So one drawdown curve influenced by another one, overlapped by another one. Now come to the theory. Many times 2 or more wells located in the same aquifer. Many times. It's obviously this will happen. Okay, 2 or more wells located in the same aquifer. Aquifer is of more than hundreds kilometers square. Okay, so 2 or more well located in the same aquifer and are close to each other, then definitely cone of depression, nothing but drawdown, may intersect. Just I told you by using this diagram. Okay, in some area, okay, 2 or more wells are inserted on the same aquifer, then definitely the cone of depression, nothing but drawdown, may intersect each other, correct? This drawdown is intersected by this. Similarly, this drawdown curve is intersected by this one, overlapped. Then wells are said to be interfere with each other, overlapped by each other, because the zone of influence of one well overlaps the other well. Correct? Zone of influence, this is the zone of influence from this yellow line point, from this yellow point to this point. The whole area is the zone of influence for well 1. Similarly, from here, orange line starts from here. So from this area to this area, okay, whole this area intersected by, okay, overlapped by each other. Zone of influence of one well overlaps the other well. Next, when closely spaced multiple well system exist, when closely spaced multiple well system exists, just imagine in some 200 kilometer squares of area, not 200, okay, let's say for example 5 kilometer squares of area, just 5 kilometer squares of area, we can expect n number of wells, correct? From this point to just after 100 to 200 meter, we can expect another well, particularly in agricultural area. When closely spaced, okay, nothing but a nearby wells. When multiple well system exist, then these are the effects. First one is total groundwater output will be less. Of course, definitely. In the same aquifer, if there are 200 wells, then definitely individual discharge will be less. In a single aquifer, if you inserted more than 100 wells, then you can expect very less discharge in individual wells. Okay, so total groundwater output will be less than the sum of the discharge capacity of the individual well. Obviously, it's quite natural. Next point, the efficiency of the each well decreases, correct? Of course, efficiency of each well decreases because you have more than 100 wells in a single aquifer. Just imagine, I'm giving an example. If there are 100 number of wells within a short area, within very less area, then efficiency of the each well, discharge in the each well, so the efficiency will be less. Next one, S mean drawdown. Drawdown increases as a result of pump lift. Of course, once you start the pumping, the water level going to be decreased. The water level will be decreasing in nature. Once you start the pumping, water level in the well, will be decreasing in nature. So water level decreasing, nothing but drawdown increases. Correct? Initially water level at this point, once you start the pumping, water level will be decreasing in nature. So this is the drawdown. Correct? Initially water level is at this point. Once you start the pumping, now the final water level at this point, so this is the drawdown. Correct? This one, drawdown. This is drawdown. Drawdown increases as a result of pump lift. Correct? Next one, pumping cost is more. This is obviously pumping cost will be more. Once you start pumping cost will be more in order to get the required discharge. Okay, this is all about interference of well and its effect. Okay.